Hello and welcome. In this video, we're going to take another look at the current P5, the one that focuses on the geometric properties of certain cross-sectional areas. And specifically, we are going to focus on a little convenience function that helps us print out the output that would otherwise go to the console and reduce a little bit of the redundant code that we have in our main. Again, this is optional, but I encourage you to follow along with this video because sometimes a function like this will actually be quite helpful in eliminating some of your extra code. And so to begin with, let's go ahead and add one more function signature to the list of prototypes that we have. We've got a couple of different ways that we can go about doing this. We can have a int return value as well as a void return value. To keep consistent with some of our other examples, I'm going to go ahead and do an int return value, which allows for us to have some logic built in. And then what I'm going to call this function is simply print f vector double. And again, it's probably not a great function name, but hopefully you will see the benefits of this function after we get done. It's going to accept a double vector. We are going to then specify the size of the vector using the variable n, which will be an integer. And the idea then is instead of us having that redundant code over and over again that would print out each of the values in the vector, we will simply allow for this little helper function to do that, and we'll simply make calls to this helper function. Now, we can make this function a little more interesting. We can actually pass the format spec to it. We can also pass the delimiter, but for this example, I want to keep this one rather simple. And so let's go ahead and copy then our prototype down, and let's go ahead and add it to the list of our functions. Perhaps we can even go so far as to add it right after our circle 2D. And again, you would want to go ahead and include a comment block that gives you some sort of description of what this function does. Again, I'm just simply going to borrow one of my other comment blocks. And let's get started on this. Let's focus then on how we can improve our print statements. And so to understand what I'm getting at here is, if you notice inside of your if statement here, after you have successfully calculated your results, that you have essentially the same code over and over and over again. In other words, a for loop, and inside the for loop, you simply index through all of the values, printing them out using the format spec, and then printing the last column with a new line. Well, it's the same process over and over again. So why don't we take a second to put it then into a function? Well, and so what we can do here is we can start off with a couple of local variables. We'll go ahead and use a results variable and a index variable. For the results variable, we're going to do just like we've done in the past. We'll have our results simply be equal to exit success until we see a problem, and then we will return our results. This means that we can benefit from a little bit of primitive error checking, meaning that we can check to make sure that our n is in fact greater than 0. And the way we want to do this is we can check to see if our n is less than or equal to 0. You could make a reasonably strong argument that an n equals to 0 is acceptable, but for our purposes, we're going to assume that we have to have at least one column for this to work. Now, inside of our if statement here, we can simply provide an error. Please provide a positive n, followed by a new line. And then, of course, just like in many of our other examples, we will simply flip then our results equal to exit failure. And then under the else branch is where we will actually do the code that will allow for us to print out our vector. And so we'll have a for loop setup that starts off with index equals to 0, index less than our n. And notice here, we're actually going to stop one column short, because again, what we're wanting to do is we're wanting to print this out horizontally per the specifications in the P5 sample. Now, again, depending on the particular project you're working on, this format, might change, but then we simply continue incrementing our index. And then inside here, you will have our printf with whatever format spec you intend to use. In this case, it's going to be our %.4f, followed by our hard-coded delimiter, and then the value at that location in the vector. And so you can see here now that what we've done is we've abstracted, or we have simply encapsulated a process that we are doing over and over again by simply passing it to a little helper function. So what vector gets passed doesn't really matter. And then outside of the for loop, then we want to do this one last time for the final column. So that's going to be, again, our %.4f for this example, followed by the new line, and then that last value in that vector. And again, that's it. This simply allows for us then to call this function. And what we will do is we will print out all of the values in the vector in one row, again, followed by the new line. And you can tweak this as necessary, perhaps for your application. You don't need that last value to have a new line because you're intending to have something after that. But let's see how we would use this then to optimize our code. And so what we'll do here is we'll come up to one of the branches of our switches, and we'll focus on our circle/I. And what I'm going to do is I'm going to change then the code for just this branch. I'm actually going to modify it the whole way down here. And so what I'm going to do is essentially I'm going to simply start back over. In other words, I'm going to completely gut our print statements. I'm going to leave the row headers alone. In other words, it'll describe for us which row we are on, all the way from the radius down to the IZ, with the difference being now is I'm going to make a call to our little printf helper, and I'm going to pass to it the radii vector and the number of elements n that it's expecting. I'm going to do the same thing now with our edge as well as the area. And at this point, I think you can probably see why I would do this, because this is going to significantly reduce the amount of code in your main. So we do this for our IX. Our IY. And our IZ. Now, let's go ahead and build this, and let's see if we notice any distinct differences between calling this interactively and calling this via the parametric switches. So we'll start back over. We'll test this one more time interactively. We're going to use the same values here. So we'll do 1. We'll go to 0.75, and then we'll do 4 values. And you can see there is my table. Now let's go ahead and call this parametrically with 1.75 and then 4 values. And unless I am missing something here, oh yes, we forgot to reverse the order. Let's go ahead and handle that real quick. You'll notice here that I'm actually starting off with the or the radius min going up to the radius max. That's an easy one for us to fix. Whereas in the parametric one, we're going from radius max down to radius min. Let's go down here real quick to our helper and fix this. And that's pretty simple. All we have to do now is we just simply change this so that it goes from n minus index -1. And then, of course, we have to do the same thing now with the last one. All right, so let's go ahead and give this a shot. We should have this set up correctly. Let's go ahead and build it. And again, we will run our interactive mode because that's the one that we actually changed. 0.75 and then 4. And again, let's go ahead and run our parametric one. And this time around, we shouldn't see any differences. So this table should 100% match this table. And again, unless there's something minor that I'm not seeing, we effectively have presented the data the exact same way on the console, with the interactive example leveraging this little helper function that simply iterates through all of the elements in the vector, printing them to the console. Now note, this won't work for every application and won't also work for every format. But in this case, you can see the difference between what you had to do for the parametric version versus what you had to do now for the interactive version. Again, hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.